dual power supply finished. And let's see the inside constructions. Here is the switching power, and you can see here is 36 volt, 36 volt and 9.7 ampere. And this is the first modular DC converter modulus. Here is the second one, and this second one has the displays installed. And first the power line is come here and go to a fuse, and then go to the power switch here and enter the input of the switching power, and then the output of the switching power go to this modulus 1, and output side of this modulus 1 go to modulus 2, and the voltage of the modulus 1 output is monitored by this voltmeter, while the output 2s can be seen on this display. And there are some voltage adjust and current adjust for two modulus. This 2 is for modulus 1, this 2 is for modulus 2, and also a sliding switch here for selection of the using of power 1 or power 2. And in the panel you can see, if you using the power 1, it can supply 9 ampere and 218 volt, 1.2 to 13 volt. The original modulus can output to something 13.6 volt, but this is too high for the input of the modulus 2, so I make some adjustment on it and lower it down to 13 volt. While the second modulus is 5A output 0.8 to 28 volt, and it's 115 voltage. And let's see the schematics. Here I roughly draw off the schematic of this power supply. The power plug here, switch, fuse to switching power, is 9.7 ampere, and then it go to the power 1 modulus, and the power 1 modulus has the current adjust is 10k variable resistor, and voltage adjust, the original design or circuit is also also is 10k variable resistor, but this will have higher output, have 13.6 volt, which is too high for the modulus 2, so I make modification by parallel another resistor here. I use 3k resistor, so the output power is maintained at 13 volt at maximum. And the output of the modulus 1 go to a slide switch. It has two selections. One is go to the output, and we can get the power of the power modulus 1 here, and it also go through a fuse for safety. When sliding switch flip to another side, then there is no output on V1, and the power and the voltage go to here. Here also voltage adjust and current adjust, and there is V2 output, and there is a voltage display here. I missed there is a voltmeter here for monitor the power modulus 1 output. To test it, okay. And now it's using modulus 1 power supply. Here I connect a motor here. Okay. Now I test the motor 2 and slide it here. Here is a small motor. Okay friends, here is my electronic components that I'm going to build a power supply. Actually it's the twins output power supply, and I have 2 step down electronic step down regulator, and also a switching power. The product spec for the two converter. The first one here, this is a step down converters. The input voltage can be from 7 to 14 volt. That my switching power is 13.6 volt. That is suitable for it, and with output 1.2 to 35 volt, and it has almost 218 volt, and also match with my switching powers, which has 315 volt. Okay, let's see another one. And need the input 5 to 13.2 volt, so I cannot directly use my switching power to input to supply the voltage to here, since it has output more than 13.2 volt, is 13.6 volt. So I need the outputs of the first step down converter go to this input voltage, and it has adjustable output 0.8 to 13 volt. The configurations will be like this. Power lines, AC power line come here and go to the switch on off, and go to the fuse, this fuse holder, Here, this is a string relief called string relief with this power cord, and go to the fuse and then go to the main switch here. Then and this will have 13.6 volt output. This output go to this step down converter, and there is two variable resistor for the adjusting the output here, the output current, output voltage and currents. And I will use a turnable knobs here to adjust this variable resistor. And I will incorporate the fuse here, so in order for some protections, there is fuse clip. Although it's not a good idea, but I just try to see if this will protect it. And this power supplies have the drawbacks that it having the output protection. If there is short circuit on the output side, it will blow. So during the operations, special care in handling is needed. And output of this will go to a slide switch here. When it's turned on, this output will have voltage linked to this another step down converter, and there will be output here. And if it's off, then this output ends will connect to this side. When it is off, there is voltage appears at these two positions, and the voltage of it will be displayed on this analog voltmeter. So I can switch either to use this output side or either to use this output side. This side will have higher power. There is around 218 voltage, while this side has less one, is almost 5 ampere and 13.2 volt. It's about 115 volt in power here, but this can be adjusted in good precisions because there is a digital output, and I can fine tune this one into a precise voltage. And here is the knob I will use here, 1, 2, for adjust the output voltage and current, which is corresponding to these two variables. These modulars need to be mounted on the carpet or the compartment, and it's a little bit difficult. And take care, don't use those screw area for mounting on the compartments. And when you disassemble this two-layer board, you will find the connection of the signal or electricity is by these 4 poles, metal poles here. So don't use this area to mount on your metal carpet. Instead, I use a plastic bracket. Now I cut this one, and you will hold there, and these four portions will be flow 19°, and this also need to have a bending here. I use a unused heating iron, solder iron to heat the floating line, and then bend it to 19 plastic bracket was made, and two screw hole M3 was filled here. Electronic motorers were installed into the compartment, and this one used two mounting screw here, 1, 2, to mount it. And for this motorers, I use the ankle bracket, aluminum, 2 screw here and 1 screw on the compartment. Care must be taken to have space there and insulation sheets on the back to prevent the short circuit, because this is the metal surface, and plastic sheets to be placed between them. Here I will install 2 variable resistors for the adjustments of these modules. This corresponding to these 2 trim ports. In usual case, I will use this type of VR, just as these 2 for these modules. But I want to use back the original variable resistor there. This type of resistor are more precise. So I'm now going to change this resistor to this one. I will disassemble it and try to mount this one on. Hello guys, and here I will show you how to modify this variable resistor. I will use this handle and the board, and remove the others, and install this variable resistor into this housing. So when I turn this handle, and I will solder this pin. This is the lead wire of the resistor. You can get this pin and check if these pins can fit into the slot of the screw head. care not to hit the metal parts too long, or it will damage the rubber resistor. I start to throw the black color plastic material onto the pin and press the pin a little bit during the welding. The screw head must be on the center as much as possible. Now on the next pin, do the same. Press it a little bit and use the material to cover that. Push the side material onto the pin. Now the result like this. When I turn this, there is a wobble. That means this is not. Now it's time to weld two lead wire on this position to fix the VR, the blue color VR. In order to rotate it, you trim the excess lead wire on the first part. Then mount another pin here. Make sure there. Now bend this lead wire a little bit and make sure a little bit solder on here. And also add a little bit hot melt glue here. And now it's finished. Now the lead wire is connected on the board. Now the switch installed on the panel or the compartment. They're here and here.